Senior as VP of Technology from ADA-ES. Thank you, Constance.
Thank you. I just want to say that I'm not a lawyer, so we've had a lot about regulations, but I'm not going to talk about those. I did once sign up for an environmental law class in college, but it was a 2-hour seminar on Friday afternoons. And I think after the first or second class meeting, I decided I had some better things to do on Friday afternoons. So that was the extent of my career in environmental law. But what I do want to talk about is compliance with MATS, and I hope everyone here is familiar with the MATS rule. It's been touched on in a number of talks, as well as in some of the roundtables yesterday. And we're not there yet for many of us in the utility industry. Compliance will be April 2015, so that's really just around the corner. Some people will have a compliance date of April 2016, but there's as we're starting to put in our systems for MATS compliance, and our company, ADA-ES, makes sorbent injection systems for MATS compliance, so we think about this a lot. I think it's worthwhile to start thinking about how are we going to actually manage that compliance. We've been thinking a lot about how are we going to spec a system, and how are we going to build the systems, and how are we going to install the systems, and how are we going to calibrate all of our CEMs or whatever we're using for measurement. But I think it's now time to sort of turn our thoughts to, well, how are we going to stay in compliance? How can we do this and hopefully minimize cost? So the topics I want to talk about, some of the things that are changing in the landscape for utilities that make some challenges for compliance. Particularly MATS is a multi-pollutant standard, so we have to be able to control multiple pollutants at the same time. I also want to bring up some ideas about measurements for compliance. You're going to have to be measuring what's coming out of the stack under MATS. Can those measurements be used for process control, or do you need some other things for process control? And then monitoring beyond just detecting that something, sorry, I can't talk without my hands, and I guess I better keep myself under control here. Just understanding how to control mercury emissions or HCl emissions in a pretty complex process where you have a lot of things going on. Changing landscape. Well, there's a lot of challenges out there for coal-fired power plants. As we saw in the last talk and other talks, there's a lot of compliance dates coming up and a lot of different things for compliance. Plants are putting on new equipment, activated carbon injection systems, ACI, dry sorbent injection systems in some cases, DSI, coal halogen injection systems, which are when you add halogens to the coal to increase mercury oxidation, as was talked about this morning. New continuous emission monitors and other instruments are going on as part of MATS compliance. In the background, of course, people are retiring, operating margins are getting thin, so sometimes plants don't have the experienced personnel that they once had, which can be a challenge. As we're seeing more natural gas and more the push for renewables, more flexibility is asked from a lot of plants, whether that's cycling or shutting down and starting up, and so that also poses some challenges for control. And then many of the things that we're going to talk about when we talk about mercury emissions compliance and HCl emissions compliance and other things are really are problems or processes that cut across different air pollution control devices. So if I'm trying to remove mercury emissions, well, I want my fabric filter to do a little bit of the work, and I want my wet scrubber to do a little bit of the work. So it's not as simple as I just put on a box and now everything's under control. So you really have to consider, for some of the pollutants in the MATS regulation, the interrelationship between different air pollution control devices. So I want to talk a little bit about mercury measurement, first of all. For many plants, you may be putting on some mercury measurement equipment for the first time. Some plants had mercury measurement equipment starting with camera, but some didn't. So for mercury measurements, you have to make a compliance measurement under MATS, and there's really two ways to do that. One is to use a sorbent trap method, or STM, and the other is to use a continuous emission monitor, or CEM, in the stack, and that's described in the MATS regulation, how you have to do that. But there are some implications for data management and for process control, depending on which of those you pick. So if you just have a sorbent trap monitor, well, that means that typically those collect mercury for about a week. You can collect for up to 2 weeks under the MATS regulation. And so that's an average of all the mercury emission for that week. Sorbent trap is batch method. You stick something in the duct, you take out some little plugs of carbon and you send them off to a lab or analyze them on site if you have the equipment on site. But there is some time delay between when the mercury is going out your stack and when you actually get the numbers. And in addition to that, the sorbent trap is really an average, could be an average over a week. So if mercury emissions were fluctuating during that week measurement time because of some process change or a fuel change, well, you wouldn't really know that. So some plants are considering, who use sorbent traps for their compliance method, are considering using a mercury process monitor at some point in the stack, typically, which is not a compliance tool, which means that it would not be subject to the strictness in terms of calibration and certification that a compliance monitor would, but it would provide some information on mercury emissions as things change in the process, as fuels change, which could be used, for example, to do process control or feedback control on an activated carbon injection system. It could also be used to kind of highlight when there's a problem before it's 2 weeks down the road, and then you find out you had a problem. The MATS rule requires a 30-day rolling average for mercury emissions, and if you're taking weekly sorbent trap measurements, that's kind of like 4 weeks that you've got. So if you have a problem, you don't want to wait too long to figure out that your mercury emissions are too high and your average may be getting up there. For stack CEMs, there you have an instantaneous output of mercury emissions in the stack. So that could, for example, be used for process control. If you wanted to, you now know where you are pretty much every minute of the day. I will point out that if plants have wet scrubbers and they're using those wet scrubbers as their primary mercury control device, there may be some advantages to measuring the mercury concentration coming into the scrubber, particularly the speciation of mercury coming into the scrubber, to see if there are process changes upstream that would change the amount of oxidized mercury coming into the scrubber. And if you remember from Mark Pastore's talk this morning, how much oxidized mercury that's coming into the scrubber, that has a big impact on how efficient that scrubber will be for removing mercury. And if you're using a scrubber as your main mercury control device, that's the last part of the train. So if you don't get it in the scrubber, then it's going out the stack. So just kind of to summarize these points, I think it's important to think about if the mercury measurements that you're using for compliance provide sufficient information for process control and process information. Real-time mercury measurement in the stack can help with process control. Some utilities have chosen to use sorbent traps. There's a number of good reasons to use sorbent traps, including cost and the amount of training required for personnel. But if you are using a sorbent trap, then the amount of data that you're getting back about mercury in your process is somewhat limited. So that's something to think about. And if using a wet scrubber as your primary mercury control method, you might want to think about having a little intelligence upstream of the scrubber to know how much mercury is coming into that scrubber. The other thing that I wanted to talk about was monitoring, what I would call monitoring beyond fault detection. In other words, not just monitoring the process to make sure that the equipment is running, but doing more to try to stay in compliance while trying to minimize operating costs. If you kind of know what's going on with your system, perhaps you can tailor your sorbent injection if you have activated carbon for the emissions that you need. Activated carbon costs can be expensive on a plant, and that's really the main cost of an activated carbon injection system. And I really believe strongly that you have to monitor the whole process to really understand what's going on with mercury control, to stay in compliance while minimizing operating costs. And if you know me, you know that I really like talking about mercury, and I could go on and on about it, which I'll try to restrain myself. But if anybody wants to talk about mercury for 5 or 6 hours, just any time, you know, I'm always there. So I wanted to give a few examples of watching the process, in trying to stay in compliance, watching the process, looking at the kind of data that's available and how you might try to use that to be smart about staying in compliance and saving money. I made up these examples, so no plant data were harmed in the making of this presentation, because I'm not going to show anybody's real plant data, but also because I've had enough experience with different configurations to kind of know some things that I've seen in various plants, and I tried to put that into some examples that would be easy to understand. So for all these examples, I synthesized a year's worth of weekly average data for my fictitious plant. And so what I'm going to be showing you is some weekly average data and how we might try to use that to make some decisions about compliance and about operating costs. So 2 examples. The first example is a 600 megawatt PRB subbituminous coal-fired boiler with a cold side ESP, and it's using activated carbon injection with brominated activated carbon as its mercury control strategy. So in this example, let's say last year the plant said, well, I'm just going to use a constant rate of 3 pounds per million ACF injection rate, and I should be set. The vendor told me that would work, and I've done some field testing, and I think that'll work. So this, we don't have a laser
Pointer.
thing. No.
Do we have our laser pointer? It's on here.
Oh, it's on here? Oh, this
That red
works?
button, yeah.
Okay.
Push it hard.
All right, so I'm going to show a series of trend graphs, and this is going to be all year, and this will be whatever we're measuring. Now, this is kind of boring because I said, well, last year we just did 3 pounds per million ACF the whole year. But say that in my boiler I have variations. I have seasonal variations. So this is January to December. I have seasonal variations in my average air heater outlet temperature. This can happen at plants, both due to load changes and due to ambient temperature changes. But this affects, this affects how activated carbon performs for mercury control. So last year, I set my pack at 3 pounds per million ACF, and these were my average emissions, and I've taken weekly averages and made a 30-day rolling average. You can see, as I said, that generally activated carbon performs better at lower temperatures. So when I have periods of lower temperature, I would expect to get better performance out of my pack and hence lower emissions. So this year, let's take a different strategy for controlling the pack. This year, I'm going to look at my past history, and I'm going to look at, where I am in terms of the 30-day rolling average, and I'm going to try to forecast ahead a little bit to see where I think that I should set my pack rate every week. So in this example, I start out at much less than 3 pounds per million because I know that I don't need that much pack in the beginning of the year, but as temperatures go up, I increase my pack rate. I'm still able to stay in compliance. I'm maybe not way down here, but I'm able to come up with a control scheme that will keep me in compliance without having to use as much pack as I did last year. And I think that sometimes we need to look at it. I wanted to put this in to say, we've learned a lot about mercury in the last 10 years. I'm not sure that we know everything that there is to know, so it's good to be able to take the data that will help you and then take a good look at it. And so I'm here all about advocating that you think about the kind of data that you need to take to make good decisions, make sure that data is available, and make sure that there are people that can look at it and help make those decisions. So I made a little, kind of a little summary of this case. Some of the information that I thought would be useful if I were trying to, on a weekly basis, assess where am I and where should I be going. I'd like to know things like what was my ACI system availability and what was my average feed rate. How does that compare to last year? How does that compare to last week? So what am I doing? What's my average mercury emission and my 30-day rolling average? And then just be able to take a look at that. And this is on a weekly basis, just because it was not relatively easy to synthesize a year's worth of weekly averages, and I didn't want to make my spreadsheet too big. But this gives you an idea of kind of the information that you should be able to collect and then use to make a good decision. So in this particular example, when I totaled it all up, so the pack consumption, the cumulative pack consumption for this year, where I'm trying to have some kind of control scheme for my pack, is less than last year's pack consumption. And this may seem obvious, and if it does, that's good, because I'm hoping people have started thinking about things this way, but it's really important now, as I said, to start thinking about what data do I need to collect to stay in compliance, and how am I going to look at it. So my second example is another 600 megawatt unit, but burning a high sulfur eastern bituminous coal. It has an SCR, a cold side ESP, and a wet scrubber. And so in this particular case, the wet scrubber is being used for compliance with the understanding that there'll be enough halogen in the fuel to oxidize the mercury, and the SCR will be helping out with the oxidation. So there'll be adequate mercury oxidation coming into the scrubber to allow the scrubber to be used as the mercury control device. Again, we often see seasonal variations, which are observed in SCR temperatures as well as air heater outlet temperatures. Variations in SCR temperature are important because, for two reasons. First, the production of SO3 in the SCR depends on the SCR temperature, and SO3 affects, in this, for bituminous plants, it can affect any native capture that happens when mercury contacts the unburned carbon. Also, SO3, the SCR temperature affects the degree of mercury oxidation in the SCR, so at very high temperatures, you don't get as much mercury oxidation in SCRs, so these temperatures are important. So I've used like a similar weekly average temperature. You can see my last year and this year, so somewhat similar. And weekly average air heater outlet temperature, a little bit higher this year in my example than last year for some reason. But as noted, there's multiple things that are going on here that affect the mercury stack emissions. And this goes from the boiler all the way to the stack. So we're using the scrubber in this case as our mercury control device, but a lot of things that happen upstream of that scrubber are going to affect how good it works, how effective it is for mercury control. And I mentioned, I think I mentioned all of these effects: temperature effects on the oxidation of SO2 to SO3, native capture in the fly ash. If you get some native capture, that's helping you out, which is affected by how much unburned carbon you have in the fly ash, how much SO3 you have in the fly ash, what the temperature is at the air heater exit. And then the amount of mercury oxidation coming into the scrubber affects how much can be removed across the scrubber. And I'm not even going to get into re-emission here. We'll just assume that we are using EES's wonderful additive, and so we don't have any re-emission on our scrubber, because that's a whole nother story. When you're using a wet scrubber as the mercury control device, you really have to, and you're not using any additional halogen, which is true for a lot of bituminous plants, you have to make sure that you're keeping up with changes in coal sulfur, coal mercury, coal chlorine content, because that can have an impact on how well you'll be able to remove mercury. So here's something else that we should be watching in this unit. This is the weekly average FGD inlet SO2. So last year and this year, so we're going along pretty well. So we're within, variations in coal quality and such, we're doing okay. In this case, let's say that we're able to measure the inlet mercury to the scrubber. So we have a continuous monitor on the scrubber inlet, which is just measuring this and telling us what the what the mercury coming into the scrubber is. Okay, time passes, and now it's later in the year. So what's going on here? Something is happening that has sent my 30-day average mercury emission. It's poking up over the MATS limit. We can look at temperatures, and we can see that, well, SCR temperatures are a little bit higher than last year, and SO2 has gone up. So something happened. There was this is obviously very suggestive of a coal change. So which changes SO3 in the flue gas. It could also change the mercury content of the coal. So for many bituminous coals, the mercury content of the coal is often well correlated with the sulfur content of the coal. So a lot of times if you have higher sulfur, you might have higher mercury coming in. And the MATS standard is an emission-based standard. It's not based on a % removal. It's based on an emission rate. So if you have more mercury coming in, you've got to remove more mercury.
Couple more.
Okay, and I have a couple more slides. So this is a case where a little investigation is required. If you have adequate monitoring, you may be able to kind of nip this in the bud. Here, we looked at the temperatures were slightly higher than last year. The increased SO2 suggested that there was a coal change. We could also look at the inlet, the FGD inlet mercury. This is total mercury. This is the inlet elemental mercury. So we can see that that's going up, and that's giving us a clue that we may have to take some action. And again, think about the data that you have to collect and how you're going to use that data to make a good decision and make it quickly so that you can respond before you're out of compliance. So I just want to conclude by saying that as we move into the new world of MATS compliance, we have new sensors that we're getting data from. We have new pieces of equipment that we're operating. We may be operating old pieces of equipment in different ways. For example, we may be operating our scrubbers a little differently if we have decided that our scrubber is going to be our main mercury control technology. So it's important to think about how to get the information that you need in order to make good decisions. And that's all I have, and I think I'm out of time.
We've got time for a couple questions.
All right.
Questions about mercury? Anybody? Yes, sir. I need to give you a prize, really, because I like questions, and I appreciate you jumping in. So that's good. Thumbs up.
Well, I'm glad I'm playing a good role for you. One question is, what has been the track record on mercury capture in wet scrubbers? I mean, has it been a consistent, reliable capture, or is it very, very much based on the scrubber type, how it's operated? And when the wet scrubber does capture mercury, does it remove it as a particulate, or is it in solution?
Well, let's see. That's a multi-part question. So let me start.
So I get extra credit?
Yeah. I really think that you should have your own microphone.
Yeah, and you've actually got 1 minute to answer that multi-part question.
Well, I don't have 6 hours. All right. Well, except for a few cases, we don't have long-term data on scrubber performance, in terms of mercury emissions from wet scrubbers. I will say that Southern Company has really been out in front and has published some papers on longer-term monitoring of scrub systems. So we don't generally know how consistent scrubbers are going to perform. When we've gone and done testing, say that we're testing coal halogen injection or a mercury re-emission chemical in a scrubber, that test might be a week or it might be a month. So long-term data doesn't really exist. Let me think of some of, what was the other question that I was going to answer? It could be either one. In the scrubber liquor, the mercury that's absorbed can be found in the liquid phase or in the solid phase, and some work on, at least on forced oxidation scrubbers, suggests that split between solid phase mercury, liquid phase mercury is dependent on the ORP. So at high ORP, most of the mercury tends to be in the liquid. At low ORP, and by low I mean below 250 or so, most of the mercury has been found typically in the solid. A lot depends on whether you have blowdown on your scrubber, what you do with the fines in your scrubber, because the mercury is concentrated in the solids, usually in the fines. I could go on, but I sense that our chairman is getting a little anxious here.
No, I'm not anxious. I'm a very relaxed guy, very relaxed. Other questions about mercury? Anybody? Well, thank you for your expertise today. Appreciate you being here. And if I could get Michael Ware to make his way up to the stage. Michael is a Saints fan. Drew Brees not having that great